beam. Filter is a material of metal placed in front of X-ray source to reduce the intensity of particular wavelength of a spectrum so that X-ray beam is restricted in its narrow wavelength range and producing a monochromatic beam by use of filter. Now figure showing use of filter. It is desirable to employ X-ray beam that is restricted in its wavelength range. In this filter technique for producing a relatively monochromatic beam by use of filter, here the K beta line, this line K beta line, and the most other continuous radiation from the emission of molybdenum target is removed by zirconium filter using a thickness of 0.01 em. Thus, pure K line is available for the analytical purpose. X-ray detectors and signal processors. X-ray equipment work with the photographic emulsion for detection and measurement of the radiation due to its speed and accuracy. But the modern instruments are equipped with detectors that convert radiant energy into an electrical signal. So, there are three types of transducers, that is detectors, are present. First, gas field detector, second, scintillation counters, and third, semiconductor detectors. Next, instrument. There are three basic types of the instrument: wavelength, dispersive, X-ray fluorescence spectrometer, energy dispersive, and non-dispersive X-ray fluorescence. Wavelength dispersive instrument. In these, tubes used as a source because of the large energy losses, collimated and dispersion of X-ray beam. Therefore, the added attenuation means loss of the signal or spectrum by the monochromator would difficult or impossible to detect and measure accurately. Wavelength dispersive instruments are of two types: single channel or sequential, multi-channel or simultaneous. Here is the tube. Here is the X-ray source tube which falls on the sample and producing the fluorescence beam of X-ray, and here the crystal and detector angle must be properly arranged. Its angle should be theta or 2 theta so that perfect signal is obtained. Next, energy dispersive instruments. As shown in the figure, energy dispersive spectrometer consists of polychromatic source. In wavelength dispersive instrument, we were used the monochromator. Here is a polychromatic source. It may be called college tube or radioactive material, and a sample holder. This is the sample holder, and a lithium drifted silicon detector and various electronic components. to differentiate in the energy. There is an absence of a collimators, and this this system gives more increase in energy reaching to the means this increase the energy which reaches to the detector. In this instrument we can use the weaker source of radioactive material or low power X-ray tube. In multi-channel energy dispersive instrument means these or these. In multi-channel energy dispersive instrument, all of the emitted X-ray lines measured simultaneously. These lines are measured simultaneously, and this increase the sensitivity and also improve the signal to noise ratio, which results good spectrum. Electron microprobe method. In the electron microprobe method, X-ray emission is stimulated or obtained on the surface of sample by narrow or focused beam of electron. This is the beam of the electron. Here three types of the radiation: electron beam, and light beam, and X-ray radiation or X-ray beam. This instrument requires a vacuum and pressure is about 10 to 5 torr and works on wavelength or energy dispersive X-ray spectrometer. The electron beam is produced by heating the tungsten cathode and accelerating anode, which is not shown in the figure. Two electromagnet lens focus the beam on the specimen stage. These are the two electromagnet lens. Finally, fluorescent X-ray produced by electron beam are collimated, dispersed by single crystal and detected by gas field detector. Here is the crystal. Now the application of electron microprobe method. The electron microprobe methods provides a wealth of information about the physical and chemical nature of a surfaces. It is also important to phase studies in metallurgy and ceramics, the investigation of the grain boundaries in alloys, and determination of diffusion rates of the impurities in semiconductors.